Welcome students. In the previous class we actually discussed about what is refraction of light and how refraction occurs and why refraction occurs. And also we know about different terms which are related to refraction of light. Okay. Now today actually we discuss about some effects of refraction of light and laws of refraction and rules of refraction. Okay, at first we have to know about laws of refraction. Okay, at first we have to know laws of refraction. Okay, in the previous class we actually discussed what is incident ray, what is refracted ray, and also what is normal. Okay, so today we know about laws of reflection. First one is actually the incident ray, normal, and the refracted ray all lie on the same plane. Okay, so the first law is actually if we draw a surface xy, this is separation line between two different medium. The above medium is called number one medium, and second one is called number two medium, and we take number one medium as rarer medium, and also we take number two as a denser medium, and we also draw a imaginary line which is called actually normal, which is perpendicular to xy or separation line of between two medium. Now this is incident ray. Actually we take AO as a incident ray, and in this case light bends and we get OB as a refracted ray, and here Mn is normal at the point of incidence O. Okay, here AO is incident ray and OB is refracted ray, and Mn is normal at the point of incidence, at the point of incidence O. Okay, according to first law, actually incident ray AO, refracted ray OB, and normal Mn lie on the same plane. Here, same planes means the plane of paper in which we draw the image. Okay, or we can say in this figure actually this rays AO, OB, and normal Mn lie on the screen. Okay, and the second law, for a given pair of medium of different densities, the ratio of the sine of angle of incidence to the sine of angle of refraction is always constant. That means we take this angle AOM. This angle is known as angle of incidence I angle, and we take BON, this angle, as angle of refraction, that is symbol as R. That means we take actually this is I angle and this is R angle, angle of refraction. Okay, so for this particular case we have to say sine I upon sine R is equal to constant. Okay, so in that case we can say the ratio of sine of angle of incidence to angle of refraction is called uh, sorry is constant. Okay, this law actually was first stated by physicist Snell. Okay, so this is actually this law is first stated by a astronomer named Willibrord Mallias. Okay, and the law is actually called Snell's law. This law is called Snell's law in short. Okay, so and also we say actually in this case we also say as sine I upon sine R is equal to mu. Okay, this is constant and mu is defined as refractive index. Okay, refractive index. If a light travels from medium A to medium B, or if we take like that, if we take above medium is air medium and the below medium is water, and at first we take light enter from air to water, light enter from air to water, then here this angle is I angle, angle of incidence, and this is R angle, angle of refraction. So in this case we actually say sine I divided by sine R, this is equal to mu. And mu, what is mu? Mu is the refractive index of water medium with respect to air medium. Okay, so we can say this is refractive index of refractive index of water with respect to air medium. And also this angle ratio, or we can say this term mu, is depend on the velocity of light in that medium, two different medium. Okay, so what is the definition of refractive index? Actually, what is the definition? Refractive index, in short we can say Ri. Okay, refractive index. Refractive index of a medium with respect to vacuum is also defined as the ratio of the speed of light in vacuum to speed of light in the given medium. Okay, if we take mu, here air and this is water, in short we can say W, or we can take water, then we can say this is equal to the ratio of speed of light, okay, velocity in air medium divided by velocity in water medium. Okay, actually this is speed of light in air medium, and this is also speed of light, but this is in water medium. Okay, so if we take a simple problem, then we can easily find out the magnitude of mu, or we can say value of refractive index. Okay, if we take speed of light in air medium is equal to 3 into 10 to the power 8 meter per second, and also if we take velocity of light or speed of light in water medium, this is equal to 2.25 into 10 to the power 8 meter per second, then actually If we find out mu W with respect to air, this is equal to 3 into 10 to the power 8 divided by 2.25 into 10 to the power 8, that is equal to 1.33. Okay, so this is 1.33 is the refractive index of water medium with respect to air medium, or we can say with respect to vacuum. Okay, or we can say from this statement actually it means light travels 1.33 times faster in vacuum than in water. Now the question is, as the refractive index is the ratio of two velocity, then it is unitless quantity. Okay, so Ri, that is basically unitless quantity. It is basically unitless quantity. Okay, because it is the ratio of it is the ratio of two same quantity, that is speed of light. Okay, so this is simple concept about refractive index. Now the question is, what are the rules of refraction? Okay, how we make refraction, or if light travels from water to air, then light in which direction light bends, and if we take light travels from air to water, or air to diamond, or air to glass, then in which direction light bends. Okay, or if is any rule regarding this? Obviously yes, actually we have to know about rules of refraction. Rule of refraction. Okay, so in this case actually at first we have to know about some rules of refraction. First, if a ray of light traveling from rarer to denser medium, then actually light bends towards the normal. Okay, so first rule is, if light travels from, this is a rarer medium, this is denser medium, and light travels from rarer to denser medium obliquely, মানে obliquely, that means actually AO AO is the incident ray, and this ray is traveled from a rarer medium to denser medium. That means we can take air to water, it bends towards the normal. Okay, this is normal MN, and the ray AO bends towards the normal, because in the denser medium actually speed of light decreases. Okay, that is why light wants to travel short distance, minimum distance. Okay, so refracted ray bends towards the normal. And what is the second law? Actually second rule, what is the second rule? Second rule, in the second rule we can say, similarly, if we take, this is xy, and this is also mn as normal, and we take incident ray like this, and this AO is the incident ray, but here this medium, our medium is denser and this medium is rarer. So in this case actually incident ray bends away from normal and we get ray like that. Okay, OB is the refracted ray. So here from this figure we can easily say this is angle of incidence and this is angle of refraction, and here also this is angle of incidence, this is angle of refraction. Now for the first figure we can easily say I is greater than R when light travels from rarer to denser medium, and also we can say when light travels from denser to rarer medium then I is less than R. Okay, so this two is the very important rule, and the third one is third rule. Actually the third rule is when a ray of light strikes the surface of separation of two medium at right angle, that is the incident ray strikes the surface normally, it travels along the same path without no deviation. So if we take like this is xy line and we draw a perpendicular, that is normal. Okay, this is normal, M O N. So in this case if we take incident ray on the surface in MO direction or on the line normal, then it actually travels along the same straight path without any deviation. Okay, so here no deviation occurs. No deviation occurs. Okay, and the fourth rule is actually in this case the path of light is reversed, it traces its path. Okay, so for the above three cases actually if the path of light is reversed then it retraces its path. That means if we take like that, this is your simple refraction rule, then we can take obviously in opposite direction also. That means if we take like that then we get this type of ray. So for the case if we take AO as incident ray, if we take AO as incident ray then we get OB refracted ray, and also if we take BO as incident then we get OA, this is refracted ray. Okay, so these are the four actually rules of refraction. For first one, when light travels from rarer to denser medium, then light actually bends towards normal. Here I is greater than R angle, and for second one case when light travels from denser medium to rarer medium, then incident ray after striking the angle of incidence point it refracted away from normal. Here R is greater than I angle, and when light actually incident on the separation line at right angle then it travels along the same straight path. And the fourth one is for the first three cases actually if the path of light is reversed then it retraces its path. Okay, so and also you have to know first the for the first rule actually I is greater than R, and here what is the deviation angle? Actually the angle by which the incident ray is deviated after refraction. That means this is deviation angle for the first figure delta, which is equal to we can say I minus R. Okay, and also for the second case here R is greater than I, so in this case we can take delta which is equal to I minus R. Okay, from this figure we can find out deviation angle. So here this is your deviation angle delta. Okay, so These are the rules of refraction. Now, what are the effects of refraction of light? Okay, so the next point is effects, actually effects of refraction of light. Actually, in the previous class, we already discussed about some effects of refraction of light. Okay, so what are the effects of refraction of light? Actually, at first we can take, if we take a pencil in the glass of water, and then the pencil appears to bend. Okay, and the second one is when we immersed a coin in the glass of water, then it actually appears to be raised. Okay, so these are the 2 points that already discussed in the previous class. Now we also take some another points like that. For example, we take the third one is actually stars appears to twinkle due to refraction of light, and also by refraction of light we can explain the actually original cause of mirage. Okay, or we can say refraction of light causes mirage to be observed in a hot sandy desert. Okay, and we also the refraction of sunlight causes advanced sunrise and sun delayed sunset. Okay, so we can say at first stars appear to twinkle. Okay, and the second one is we can say explanation of mirage with the help of refraction of light, and the third one is about advanced sunrise and delayed sunset. Okay, so these are the actually some effects of refraction of light. Okay, now we take a simple activity. Okay, so this is your last topic for today's class. Okay, so if we take a simple rectangular slab like that, in this case, if we take a simple rectangular slab, this is actually activity based problem. Okay, if you understand what is refraction and how refraction occurs, and what is the condition of refraction, then you can easily find out. Okay, so here we take a rectangle slab that is PQRS. Okay, so here PQ is parallel to RS side. Okay, and a ray actually angularly incident uh, on the surface PQ, that is we take as AB. Okay, so this is your incident ray. So for the first case, actually if we draw a normal at point B, then actually AB travels from, this is your air medium and this is a rectangular glass slab, that means this is glass. Okay, and also this is air medium. So at first AB incident ray travels or incident angle on the surface PQ. Okay, after reflection actually light bends towards the normal because of light travels from rare earth to denser medium. That is why incident ray bends towards the normal, and after reflection we get BC ray. Okay, this is BC ray, and BC ray incident on the surface SR, that is also angle, and that is why in this case for SR surface, BC is the incident ray, and this ray actually travels from glass to air medium. That means denser to rarer medium, and we get refracted ray which is away from normal, and we get ray like that. Okay, this is your CD. Okay, so we can say AB is, in this case, actually we take AB as incident ray, and in this case CD actually emergent ray. We can say this is emergent ray, and also actually BC is refracted ray. Refracted ray. And for the particular case, if we name like that, actually in this case if we name, this is actually N, this is X, okay, this is M, this is Y, and here this is your angle of incidence. Okay, I is angle of incidence, and here actually this angle is R, okay, angle of refraction, and this angle is E, that is E is angle of emergence, okay, angle of emergence, and also R is angle of refraction, okay, angle of refraction. Here we also know, or we can say that actually AB, which is parallel to CD ray, as PQ is parallel to RS, so using the geometrical rule we can say this is your same angle R, okay. So if we take, then actually this is MX, okay. So in this case we easily say AB parallel to CD, and also we can say I angle is equal to E angle. That means angle of incidence is equal to angle of refraction. Okay, so this is the end of today's class. Okay, so in the next class we discuss about refraction through a glass prism and what is the dispersion of light. Okay.